Hello, welcome to Power of Dates 5 by Danny Tech. Today we talk a bit more about service endpoints and about one example use case that they can enable, which is digital product passports. When we resolve deeds to DID documents, then often we are primarily interested in the verification methods which enable authentication and secure interaction with the DID controller. However, another very powerful feature of DID documents is services. Services provide mechanisms for interacting with the DID subject using protocols such as DIDCOM, Decentralized Web Nodes, ActivityPub, or others. But services can really also simply be links to files or web pages which contain information about the subject. If the DID subject is, for example, a physical product, then a service can point to a digital product passport. Technically speaking, a service can be selected from a DID document using the service DID parameter. And then we're no longer only talking about resolving DIDs to DID documents, but about dereferencing DID URLs to service endpoints. This dereferencing mechanism inherits all the beneficial properties of DIDs themselves. It is decentralized, it is cryptographically verifiable, and it is persistent. And that last property, persistence, that one is especially interesting. Since we are able to update DID documents without having to change the DID, we can establish an indirection mechanism which provides location independence and data portability. This concept of having location-independent identifiers is not new and has always been considered valuable for the web. Since the 1990s, communities have been working on something called persistent URLs, also known as PURLs. However, these identifiers have always been persistent only because of convention or social or legal contracts. DIDs and DID URLs, on the other hand, are persistent because that is technically enforced by the underlying DID method. DID URLs, therefore, provide a very powerful way to link directly to information about a DID subject. Let's look at an example now. So here's a DID document and here is a DID. This looks all very familiar so far. The DID can be resolved to the DID document, and the DID document in turn, of course, contains the DID itself. Now we can select a service from the DID document by adding the service parameter to the DID. And this then becomes a so-called DID URL, which can be dereferenced. When the DID URL gets dereferenced, the dereferencing software selects the service from the DID document whose ID matches the value of the service parameter in the DID URL. And the dereferencer then extracts the service endpoint value from the DID document from this specific service and returns it. This is the result of the dereferencing process. And as I mentioned before, the service endpoint could change over time, but the DID itself remains persistent. This is already a very powerful process. However, there are also some additional features that can also be used. For example, it would be possible to append another DID parameter called relative ref to the DID URL. And in this case, the result of the dereferencing process would be the same service endpoint with that relative reference appended to the result. This basically means that DID URLs can be used not only for identifying a single service endpoint, but also as a root of an entire namespace. One additional feature that could also be used is the version time DID parameter, which makes it possible to resolve DID documents at an earlier point in time. If we do that, then effectively the result of the DID URL dereferencing process would be an earlier location of that service endpoint. We begin by resolving a DID to its DID document, and we will see that the resulting DID document contains a service named product, and the service endpoint has the URL of the location of a digital product passport on a website. Now, on the command line, we can show how we can select that service from the DID document by appending the service DID parameter to the DID URL. And by executing that command, we are dereferencing the DID URL, and the result is the service endpoint of the digital product passport from the DID document. We can also experiment with the relative ref DID parameter. which allows us to append a relative path to the did URL. And when we dereference that, then the result is the service endpoint from the did document with the relative path appended. This means that we can effectively identify any number of resources relative to a root namespace associated with the product. We can also use the version time did parameter in order to dereference the did URL at an earlier point in time. We will see that the service endpoint at that time was different. And if you think about it, this is a really powerful feature because it means that we can have a stable, persistent identifier and we can access a transparent, immutable and auditable history of all the data associated with the product at any point in time. Finally, I'm going to show what happens when we take a resolver and the did URL and open that using a standard web browser. When we do that, then again the did URL gets dereferenced and the web browser is automatically redirected to the service endpoint from the did document. This is a really useful behavior and feature because it means that we can put persistent did URLs into hyperlinks or QR codes and open them using existing software and infrastructure. To summarize, we looked at how decentralized identifiers can be used as an indirection layer for endpoints or simply for any kinds of links that point to information about the subject or a resource. In the case of physical products, a did URL can serve effectively as a persistent deep link, which can be dereferenced to a digital product passport, and this works nicely without the need for any central registries. Besides this product use case, we believe that there are also countless potential other applications where such stable, persistent links can be useful. Thank you and goodbye.